The introduction for this research is esterification is a significant industrial process used in the manufacture of ethyl acetate, which is widely used as a solvent, flavoring agent, and fragrance in a range of sectors. Because the reaction is naturally balanced, employing acid catalysts will increase the product's yield. The process can be catalyzed by a range of catalysts, including zeolites, mineral acids, and ion exchange resids. Reactor design, reaction circumstances, and catalyst choice can all have a significant impact on the reaction's yield and selectivity. The homogeneous catalyst application has always been recognized as challenging due to the challenges of recycling, separating, and corroding the equipment.
The research background for our research is zirconium carbide nanopowder was produced and employed as a novel ceramic solid acid catalyst for acetic acid esterification. The catalytic active atoms and centers, as well as the kind of related orbital in the Lewis acid catalytic process, were computed using ZRC's electronic band structure and partial electronic density of state, which is PEDOS. The proportion of acetic acid converted to ethyl acetate was determined by titration of residual acetic acid. As a solid acid catalyst in the conversion of acetic acid to ethyl acetate, ZRC performed admirably.
The first objective for this research is to enhance catalytic activity. This is to examine and show that the zirconium carbide nanopowder catalyst has better catalytic activity than conventional catalysts in accelerating the esterification reaction, which result in higher ethyl acetate yields. Second is optimization of reaction condition. This is to establish the ideal reaction parameters for the esterification synthesis process utilizing the zirconium carbide nanopowder catalyst in order to maximize conversion rates and selectivity.
The main topic of this paper is about the ethyl acetate esterification reaction. Esterification reaction is an important industrial process for the production of ethyl acetate. Chemists will use the right catalyst to increase the yield product of the reaction, and one of the useful catalysts in industrial processes is zirconium carbide because it has a high degree of chemical and mechanical stability. The application of zirconium carbide nanopowder's superior ceramic solid catalyst is discussed in this topic.
Okay, next is method. There are three parts of methods. The first one, characterization of catalyst. The second one, preparation of zirconium carbide solid acid nanopowder. And the last one is esterification of acetic acid and ethanol.
Based on the result, the XRD pattern of zirconium carbide was shown in Figure 1 where the intensity versus temperature graph was plotted. Figure 2 shown the SEM image for ZRC solid acid nanopowder which the homogeneity of sample on a larger scale. Besides, Figure 3 shown the amount and strength of acidic and basic site of ZRC solid acid nanopowder by NH3-TPD method. For characterization of catalytic active center, Figure 4 shown the partial electronic density of state of ZRC where the DOS versus energy graph was plotted.
Next, for the discussion part, the catalysts were characterized by few techniques such as XRD, where pattern of the zirconium carbide solid acid nanopowder shows similar diffraction patterns to standard one. SM that show the homogeneity of the samples on a larger scale, band analysis to identify surface area of catalyst, and NH3-TPD method to characterize amount and strength of acidic and basic sites of the catalyst. The characterization of catalytic active center shows that the d orbitals of the zirconium provide suitable position for Lewis acid catalytic reactions.
Chapter in discussion, which is reusability of the catalyst. The reusability of the catalyst of zirconium carbide was demonstrated over 5 consecutive runs without significant loss of activity, highlighting its potential for industrial applications. The catalyst filtered, washed and dried after each reaction and showed no leaching no leaching or loss of the catalytic activity during the consecutive runs. The high reusability of the zirconium carbide catalyst positions it as a promising and sustainable option for the esterification of ethyl acetate in industrial processes. Chapter in discussion, which is esterification reaction. In this process, zirconium carbide solid acid nanopowder was used as a catalyst for the esterification reaction, resulting in high catalytic activity and recyclability for the industrial applications. The esterification reaction between acetic acid and ethanol is to produce ethyl acetate and water. The zirconium carbide used as a catalyst is based on the optimal conditions that can produce high substrate conversion that indicate the effectiveness of the catalyst in promoting the esterification reaction. Overall, this study is to demonstrate the potential of zirconium carbide solid acid nanopowder as a viable catalyst for the esterification of ethyl acetate that can give high catalytic activity and recyclability, thus gives the high producing yield.